So, in the last class, we're looking at how to write the correct formulas of compound using the concept of valency. I said two compounds or two elements or an element or a radical or two radicals, whichever one, can actually only combine if they have what there opposite charges, because opposite charges were there attract. That was the case. And I said when you have two opposite charges, one being positive, the other being what? Negative. What happens then now? They will exchange parts, right? And ignore the sign, just bring the parts, and that was all. We said in a case where they have the same power, what happens then now? We'll cancel out. That was like the concept there. Let's look at something else, please. Number of particles. Look at number of particles in an element or ion. Number of particles in an element or ion. Read there. So now in the very first class, we define an element as what? A chemical substance which cannot be split by any chemical means. Defined as an ion as what? An element or a compound bearing an electrical charge. Let's look at this concept, please. The number of particles in an element or ions. We discussed atoms in our previous class. We said an atom has three particles. That's your electrons, your protons, and your neutrons. Now I tried to describe an atom. I said for an atom you have electrons revolving around what there? The nucleus. I said in the nucleus you have what there? Protons and what? Neutrons. Right? That means for an overview there, an atom has three particles there: protons, electrons, neutrons. If I'm given a particular element, how do I know the total number of protons, total number of electrons, and then total number of what? Neutrons? How do I know? Think about it. Note. Here, alright, please. Here, we try to get the number of protons, neutrons, and electrons. Here, we try to get the total number of protons, neutrons, and electrons in an atom of an element or an ion. Here, we try to get the total number of protons, neutrons, and electrons in an atom of an element or an ion. Alright, note that you can say record the following if you want to. Record the following. Record the following. Number one. Record the following. Number one. For a neutral atom, number of protons equal to number of electrons. For a neutral atom, number of electrons equal to number of protons. Full stop. Number two, atoms gain electrons to become negatively charged. Number two, atoms gain electrons to become negatively charged. Number three, atoms lose electrons to become positively charged. Number three, atoms lose electrons to become positively charged. Let's have a look at this. Let's start with this. The question is this: how do I know that an atom is neutral? That's the question. If I'm given an atom, how do I know it's neutral? What do I look out for? How do you know it's neutral? An atom is neutral when it has what there? No electric charge. That's all. Right? When an atom has no electric charge, it comes from there, it's neutral. Hence, elements are usually, like if I write the symbol of an element is neutral. That means ions are actually what they're not neutral. That's like the concept. Let's do this. Let's say I have this. Let's say I have this compound, okay? Mg. What's Mg? Magnesium. Right. So I'm having Mg as magnesium. Magnesium is atomic number what, please? 12. Alright. If it's atomic number 12, what's the number of protons? How many protons? How many neutrons? How many electrons? Huh? Huh? Okay, note. The atomic number of an element is equal to the number of protons. It's equal to the number of protons in an atom of that element. The atomic number of an element is the number of protons in an atom of that element. Alright. So if I have this man having atomic number 12, how many protons there? 12 protons. So protons P is equal to 12. For this one here, how many electrons? How many electrons? Huh? What you have here, is it neutral or is it charged? It's neutral. For a neutral atom, what happens? And what? So how many electrons here? 12. This becomes a neutral atom. For a neutral atom, what happens there? I have equal number of what? Protons and what? Electrons. Alright, so how many neutrons do I have here? So I have 12 protons, 12 electrons, because it's neutral, there's no charge on it. I'm having it. How many neutrons do we have for this? Actually 24. Alright, sorry, 12 neutrons. So I have 12 neutrons for this. Is it always the same thing? No. I will explain how you get neutrons much more later. Alright, let's finish up this. I want to show some first. So let's just work with just protons and electrons for now. I will show you how to get neutrons much more later. Alright. Now compare this. Okay, so let's leave out neutrons for now. Oh, should it be there? Should be here? Alright, let's leave it here. Compare this with magnesium ion 2 plus. Compare this with magnesium ion 2 plus. Case 1. Let's start with number of protons. For a magnesium ion, how many protons do you get? Now, hang on. Let me give you a hint for this, please. The number of protons in an atom of an element is usually constant. It doesn't change. So whether it's an ion or it's not an ion, it's a constant. Alright, so how many protons here? 12. Why? Because the atomic number of magnesium is what? 12. Let's get electrons. So if I'm asked to find number of electrons here, what I'll do is this: ask yourself, this atom here, is it a neutral atom? It's not a neutral atom. Why? It contains an electric charge, so it's not neutral. Now, next up, look at the kind of charge it's containing. I'm having a positive charge there. Positive charge, for an atom to become positive, is it gaining electron or losing electron? It's losing electron. That's why it's positive. Please, how many electrons has this man lost? Has lost 2 electrons. Let's assume this was to be neutral. If it was neutral as in this case now, I'll have 12 protons and 12 electrons. But this one means it has lost 2 electrons. So if I had 12 normally and I lose 2, how many will we get next? It becomes 10 electrons. This is how you have solution like this. This is how you have solution like this. Let's take chlorine for instance. Cl, that is chlorine. Let's get number of protons, number of electrons. I said, let's leave out neutrons for now. We consider neutrons much more later. Chlorine. For chlorine, how many number of protons do you have for chlorine? 17. Why? That's the atomic number. Having 17, yeah? Observe, here's a neutral atom. How many electrons? C17. Get the chlorine ion, that's this. This now becomes number of protons, always constant, 17. Number of electrons. For number of electrons, I'm having a negative. What does it mean? It has gotten 1 electron. So just 1. So 1 plus 17 gives you what there? We're having 18 electrons. This is how it works. This is how to get number of particles. In the JAMB exam, they'll say the number of electrons, comma, protons, and neutrons in the atom given below are dash, dash, and dash. You'll see it. I'll show you how it works. So please don't stop. Let's discuss something called Nuclide Symbol. Let's discuss Nuclide Symbol. Take that, please. The nuclide symbol of an element is the symbol of that element. The symbol of that element showing its atomic number and mass number. Showing its atomic number and mass number, in brackets, atomic mass. Showing its atomic number and mass number, in brackets, atomic mass. Given, full stop, take a paragraph there. Paragraph. Given an element X. Given an element X. Having atomic number Z. Given an element X. Having atomic number Z. And mass number A. Given an element X having atomic number Z and mass number A, its nuclide symbol is written as X, Z, and A. Comes X, Z, and A. What does it mean? It means to get number of protons. Look at this value here. Number of neutrons, or the atomic number, this one, yeah? Mass number, this one here. So note something. Note something. Number 1. Note number 1. Note number 1. The atomic number of an element is the number of protons in an atom of that element. We said this already before now, but note it please. The atomic number of an element is the number of protons in an atom of that element. While the mass number is the number of protons and neutrons in an atom of the element. While the mass number, also called atomic mass, is the number of protons and neutrons in an atom of that element. So I'm saying this. I'm saying that atomic number is equal to number of protons, also mass number is equal to number of protons plus what there? Number of neutrons. So please, there is no electron in this case. There is no electron in this case, right? Number of protons, number of neutrons. If you check your biochemistry, you'll see the mass number of each of the elements, whatever, right? Just one example, we are off of this, right? Just one example, we are off of this. Let's say I'm giving hydrogen, H, 1 plus. Example, H, 1 plus. What what is the number of protons, electrons, and neutrons in this ion? What's the number? Huh? Okay, don't worry. So, this is actually an isotope of hydrogen, Abi. Hydrogen has 3 isotopes, right? Protium, deuterium, and what? Tritium. But let's just stop there. Let me use tritium here. Let me use 3 here instead. Let me use tritium. An isotope of hydrogen. I have this here. So if I'm asked to find number of protons, electrons, and neutrons, what do I do? Look at it. Number 1, we said number of protons equal to what there? Atomic number. If I'm having this here, which of these shows the atomic number? This one here. That means number of protons is equal to what there? 1. That's the first task. Next up, how do I get neutron? We said neutron is equal to what there? Protons plus, mass number is equal to what there? Proton plus what? Neutron. Here's my mass number, 3. That means if I combine proton plus neutron to be equal to what there? The mass number, 3. That's the concept. How many protons do we have here? We said 1. So it means 1 plus neutron is equal to what there? 3. How do I get n here? Move this over here. So it means that I have my neutrons being equal to 3. My constant comes what there? Minus 1. 3 minus 1 gives you what there? 2. So I have 2 neutrons. Let's get number of electrons. How do I get electrons? First of all, let's assume this was a neutral atom. If it was neutral, what does it mean? Number of protons equal to what there? Number of what? Electrons for a neutral atom. But it's not neutral. Why? It has an what? Electric charge. What's charge here? Positive. Before then, when it was neutral, number of protons equal to number of electrons. That means my proton is equal to my number of electrons. How many there? 1 for a neutral atom. But in this case now, it's charged. It's not neutral. What is charge here? Positive. For positive, has it gained electron or lost electron? It has lost electron. So it has lost 1 electron. That's why it's just plus. So I also have 1 electron here, but I've lost 1. So how many electrons do I have here? 0. I have none. I've lost the only one I had. I've lost it. So in total, how many protons here? This man has how many protons here? 1. How many electrons here? 0. How many neutrons here? 2. That's the answer. 1 proton, no electron, 2 neutrons. That's the concept. This is not readily true. This is not readily true. In your JAMB exam, listen, this is not readily true, but it's something close to the answer. In your JAMB exam, this one is easy to know. Why? Because I've been given these 2. So I'm giving atomic number and mass number. So it's easy for you to get those stuff. But in JAMB exam, you may not be given these values. They just give you Ca2 plus. That means they're giving you this now with an expectation that you know the atomic number and the mass number. That's the expectation there. What if you don't know? What do you do? Always note this, that the mass number of an element is usually 2 times the atomic number, or 2 times the atomic number plus 1, or 2 times atomic number minus 1. Always like this. The mass number of an element is usually 2 times its atomic number, as you can see here, 40, or 2 times atomic number plus 1. There are elements like that has plus 1, and then 2 times atomic number minus 1. For the random, just take 2 times atomic number to give you a good range, right? So you go check your lab chemistry. Check, you see a table that contains all the elements and their mass number. All right, let's get started, please. For this, how many protons? P. Protons is equal to atomic number 20. Easy. Next up, how many neutrons? We said protons plus neutrons gives you what there? Mass number. So how many neutrons here? How many? 20. Why? 20 plus 2 gives you what there? 40. Finally, how many electrons? How many? Usually it should be 20. For a neutral atom it should be 20. But I'm having 2 plus. 2 plus means that it does 2. So 50 minus 2 gives you what there? 18. So 18 electrons. Please remember this thing. Remember this, right? So that's what works. Right. Another important concept you should note in this is this. In chemistry is this. So many please. How to calculate the relative molecular mass of the compound. Alright, so let's look at a new concept, calculating the relative molecular mass of the compound. Right? Usually, when you ask to find the relative molecular mass of a compound in JAMB, it is expected that it will give you the relative atomic mass, right? So let's say I'm asked to calculate the relative molecular mass of this compound. It is expected that it will give you these values. These are called the atomic masses of each of the atoms that you need here. It's expected that you give me this value, but in some cases again, you may not be given. You may not be given. So I said, if you're not given, take a good guess. 2 times atomic number, 2 times atomic number plus 1, 2 times atomic number minus 1. I would advise go back to your biochemistry, check it's there. It's there, or you can just browse them, write them out, try to cram them. Shouldn't be difficult. Like observe for potassium. For potassium, K. Atomic number what there? 19. 19 times 2, 38. Plus 1, 39. So you can see this case here. It's 2 times atomic number plus 1 in this case here. Right? So my master is what do I do? I'll do just 1, another 2 also. 1 and 4. You go to 2 and 3 for me. Right? That's 1 and 4. I'm having this compound CH2O. Alright. I'm asked to find the relative molecular mass of this compound. What do you do? Look up. It's as easy as this. Start with carbon. Carbon here, the relative atomic mass is 12. It becomes 12 for carbon. Plus, next up, I'm having hydrogen. The mass of hydrogen is 1. But the thing is this, I have 2 atoms of hydrogen because of that times 2. Plus, finally for oxygen, I have 16 there. Becomes 16. This is now equal to 12 plus 1 times 2 is 2 plus 16, that's 16. Combined this is 14 plus 16, how many there? 30. 30 what? I have 30. What's the unit for this molecular mass? Gram per mole. On what? It's actually 30 gram per mole. Or in higher, if you come to IRC here, higher side, we call it AMU, right? AMU, so 30 gram per mole on the AMU. AMU actually means atomic mass units, but that's in the tertiary concept. That's the AMU. So I'm having 30 gram per mole. So the unit for this, the unit for relative molecular mass is gram per mole. I'll do number 4. Start there. So you try out 2 and 3. Number 4, I have this, and this. What's the name of this compound? What's the name of this compound? So look at how to also name inorganic compounds. Potassium heptaoxo dichromate 6. That's a compound. Potassium heptaoxo dichromate 6. Alright, let's get to my numbers. So I think we'll do some in the next class, right? So I need time. Then you need time to explain the whole concept. If you start now, we're not finished. Need time to show you how it's done. I'll first of all give you the first two elements. I'll give you their valencies. See how to name them, right? Let's do this done, please. How do I get the relative molecular mass of this compound? Same concept. Potassium, what's the number M? 39. That's 39, okay? I'm having two atoms, so that's 2 plus which compound? What compound is CR? Who's a CR7? No. Chromium. What's the number here? 52. How many atoms? 2 of it. Oxygen, what's the number there? 16. How many atoms there? 7. Help me multiply. This is 78. This is 104. This is 112. 112. Add them up. This 6, this 4, 1, this 8, this 9, 294 gram per mole. Please confirm value. Huh? Confirm this value. I'm not watching. Correct. 294 gram per mole. So can we do this? Can we finish it up? Huh? Alright. This is. So you finish up. You spend time. What should be when you go home? Look for examples. Carry your textbook. Solve those stuff. I said this before in this class. I'm saying it again, please. Great teachers don't make great students. Great students make themselves from the instructions of great teachers. It's all on you. Passing is all on you, not on me. I'll do my best, but follow what I'm saying. The instruction now is this. When we are done here, go back, pick up textbook and solve examples. Go online, look for something, solve examples. That's my advice. Alright, somebody please. Let's look at the next concept.